The signal from 500 million light-years away just stopped. For 1,642 days, it repeated every 16.35 days with perfect precision. Then nothing. Scientists at the Canadian Hydrogen Intensity Mapping Experiment checked their instruments 47 times. Everything worked perfectly. The signal itself was gone. What happened next terrified astronomers across 19 countries. This wasn't random cosmic noise. This was FRB 180916.J0158+65. The only repeating fast radio burst ever discovered that followed a predictable pattern. It pulsed with the energy of 500 million suns compressed into milliseconds. And for reasons nobody understands, it broadcast on a schedule more precise than any atomic clock. Until March 2023. That's when Dr. Kiyoshi Masue at MIT noticed the absence. 4 cycles passed. Nothing. 8 cycles. Silence. The most mysterious signal in human history had vanished. And what scientists discovered in those final transmissions changed everything we thought we knew about the universe. The CHIME telescope in British Columbia detected it first. September 16, 2018. A burst of radio waves so powerful it registered instantly across all 1,024 receivers. The team dismissed it. Fast radio bursts happen constantly. Dying stars. Colliding neutron stars. Cosmic accidents. But then Dr. Pragya Chawla noticed something impossible in the data. The burst repeated. January 2, 2019. Same source. Same frequency. Then January 18th. Then February 3rd. Each exactly 16.35 days apart. The entire astronomy community went silent when she published the pattern. In the 15 years since astronomers discovered fast radio bursts in 2007, nobody had seen anything like this. The Arecibo Observatory in Puerto Rico confirmed it. The European VLBI network confirmed it. 8 different telescope arrays across 4 continents all saw the same thing. A radio signal from Galaxy SDSS J015800.28 plus 654253.0, pulsing every 16 days and 8 hours with mathematical precision. The source? A spiral galaxy 500 million light-years from Earth. To put that in perspective, the signal started its journey before complex life existed on our planet. Here's what nobody expected. The burst didn't just repeat on schedule. It followed an internal pattern too. 4 days of activity. 12 days of silence. Like clockwork. Dr. Masue assembled a team of 63 scientists across 11 institutions. Their single mission, figure out what was sending this signal. But here's what they didn't know yet. The answer was going to be far stranger than anyone imagined. The data got weirder. Between January and August 2020, the team logged 38 complete cycles. Every single one perfect. 16.35 days. Never early. Never late. Accurate to within 7 minutes across 616 days. Natural cosmic phenomena don't do this. Pulsars spin with precision, but they pulse every millisecond, not every 16 days. Binary star systems orbit predictably, but their signals fluctuate. This didn't fluctuate. Dr. Frans Kirsten at the Netherlands Institute for Radio Astronomy calculated the odds. A natural phenomenon producing this exact pattern? 1 in 847 billion. The team started mapping the source with unprecedented detail. They used very long baseline interferometry, linking telescopes across 9,000 kilometers to create a virtual dish the size of Earth. What they found stopped them cold. The signal originated from a single point. Not a region. Not a cloud. A specific location smaller than our solar system. And it sat inside a star-forming region of the galaxy. New stars. Hot gas. Magnetic chaos. The worst possible environment for a stable signal. Yet there it was. Pulsing through cosmic interference that should have scrambled it into noise. Dr. Chawla ran the numbers again. The burst released 1.3 times 10 to the 35th joules per pulse. That's the energy our sun produces in 84 years, released in 3 milliseconds. Something was generating power on a scale that broke our understanding of physics. Then in June 2020, they detected something new. The signal changed frequency mid-burst. It started at 600 MHz, dropped to 400, then spiked to 800 before cutting out. Like someone turning a dial. Dr. Jason Hessels from the University of Amsterdam said it out loud first. What if this wasn't natural? The room went quiet. Because if something intelligent was sending this signal, the implications were unthinkable. And what they discovered next made that possibility impossible to dismiss. November 2022. The team identified the source object. A magnetar. The most magnetic object in the known universe. A neutron star 20 kilometers wide, spinning 3.2 times per second, wrapped in a magnetic field 1 quadrillion times stronger than Earth's. This should have solved everything. Magnetars produce fast radio bursts. Scientists had suspected this for years. But magnetars are chaotic. Violent. They flare randomly when their crust cracks under magnetic stress. They don't broadcast on schedules. Dr. Mosway found the problem in the timing data. The magnetar was in a binary system, orbiting something every 16.35 days. The pattern finally made sense. Every orbit, the magnetar passed through its companion stellar wind. The interaction triggered the bursts. Perfect. Predictable. Natural. Except for one detail nobody could explain. The companion star was too small. Too dim. The stellar wind wasn't dense enough to trigger bursts this powerful. Dr. Astrophysicist Deborah Good ran simulations at the University of British Columbia. She modeled 10,000 scenarios. None produced the observed pattern. The physics didn't work. Unless the companion wasn't a star at all. What if it was artificial? A structure. Something built. The team dismissed this publicly. Too speculative. Too dangerous for their reputations. But privately, 3 scientists started analyzing the signal for patterns within patterns. They found them. The frequency changes weren't random. They followed a mathematical sequence. Prime numbers. 2, 3, 5, 7, 11, 13. Repeating across 6 bursts in April 2021. Dr. Kirsten buried this finding. Never published it. Because if the signal was intentional, someone was trying to communicate. And they'd been broadcasting for at least 500 million years. Long before humans. Before dinosaurs. Before multicellular life. Then March 14, 2023 happened. Cycle number 108. Nothing. The signal stopped. 4 teams checked independently. CHIME, Arecibo's replacement, the 500-meter aperture spherical telescope in China, the Meerkat Array in South Africa. All confirmed. Silence. Dr. Mosway made 23 calls in 6 hours. Every major observatory on Earth turned toward SDSS J015800.28 plus 654253.0. They watched for 90 days straight. The magnetar was still there. Still spinning. Still erupting with X-rays. But the 16-day radio signal? Gone. Like someone flipped a switch. Here's what keeps astronomers awake now. That signal traveled for 500 million years to reach us. We detected it for exactly 1,642 days. A cosmic blink. Was it meant for us? Was it a beacon that served its purpose? Or did something 500 million light-years away simply die? We'll never know what sent it. We barely understand what stopped it. But FRB 180916 taught us something terrifying. The universe is full of patterns we don't recognize. Signals we can't decode. Intelligence we might not survive meeting. Right now, 47 observatories are listening for the signal's return. They're cataloging 14 other repeating fast radio bursts, hoping one shows a pattern. So far, nothing matches the precision of FRB 180916. Dr. Mosway's team still monitors the source every 16.35 days. Just in case. Because if that signal returns, if it changes, if it responds to anything we've transmitted, we'll know we're not alone. And we'll know something out there wants to be found. If a mystery this deep kept you watching, subscribe. We explore the darkest corners of space every week. And here's the question nobody's asking yet: what if the signal didn't stop? What if we just stopped being able to hear it? Subscribe for a new dark truth every day.